So we have completed almost all lap winding types: simplex, duplex and multiplex lap windings with full pitch coils and fractional pitch coil spans. Now take this as an assignment and submit me on 21st September, that is on Monday. Huh? Okay, so this is a first assignment. I will be giving assignments regularly, and each assignment will be carrying 5 marks. So at last we will be taking the average of these assignments. Okay, so finish this and submit me by Monday. Okay, right. So this is a lap winding and 6 poles, 18 slots, 4 coil sides per slot, 4 coil sides per slot. So this is the problem. So you need to draw a simplex full pitch progressive type, that is YC equals to +1 lap winding diagram, and also indicate the brush positions, identify the parallel paths, and draw the EMF induced across the terminals. So this is your problem, assignment problem. So do it by Monday and submit to me. Okay, so today I will be taking wave windings, but before I go into wave windings, I just wanted to give one more important what do you say, concept regarding the lap winding. So equalizer rings. Equalizer rings actually used in lap winding machines, lap winding DC machines, to minimize, not completely eliminate, but minimize the effect of, or minimize the effect of circulating currents due to unequal EMFs induced in the parallel paths. Okay, so the purpose of equalizer rings is to minimize the effect of circulating currents which are caused due to unequal EMFs induced in the parallel paths, because we have so many parallel paths in the lap winding. Okay, so all EMFs induced in these paths should be equal in nature, otherwise there will be a circulating currents in between these loops. Okay, so to minimize this, so we have many parallel paths in lap winding, and if EMFs induced in these parallel paths are not equal, then we will be having circulating currents among these parallel paths. So to eliminate or minimize the effects of these circulating parallel paths, currents, we use the equalizer rings. Okay, now now why this unequal EMFs induce? Why this unequal EMFs induce? There are so many reasons. For example, if I quickly draw the four pole machine like this. Okay, so if suppose this is north south, so the flux lines will be, this is core. Okay, So okay, so these are the magnetic flux lines, right? So if the reluctance offered for each loop is not same, then due to aging and wear and tear of bearings, what happens, the rotor or armature might slide bit towards some end. It might slide towards some end, and what happens then, this distance from the pole to the armature may be greater than this distance. Okay, so the coils, the EMF induced in the coils on this side will be less than this side. So that is also one cause due to aging and wear and tear of bearings. There may be shift in the armature and may cause unequal EMFs induced in the parallel paths. Okay, and the third reason may be the poles and pole shoes. We will arrange the poles to the stator, and there may be unequal lengths. These poles, there may be this length and this length may be slightly different, that will cause the overall distance from the pole shoe to armature varying from this to this. Okay, so irregularity in pole arrangement. Okay, so these are the basic means to have a unequal EMFs induced in the paths, and these unequal induced EMFs will cause the circulating currents in the loops, parallel paths. Okay, now how do we eliminate these currents? How do we eliminate these currents? Now I have shown here simple example. So this is a 4-pole 12 slots 12 coil example. This example we have already taken in the first lecture of winding. Then we have the bushes 1, 4, 7 and 10 like this, and we have the parallel paths and the corresponding coils 1 dash 2 2 dash 3 3 dash and 1 parallel path, 4 4 dash 5 5 dash 6 6 dash and second parallel path, 7 7 dash 8 8 dash 9 9 dash. Okay, so 7 7 dash 8 8 dash 9 9 dash in the third parallel path, and 10 10 dash 11 11 dash and 12 12 dash in the fourth parallel path. Okay, so we have 4 parallel paths, and we also know the coil numbers in each parallel path. Okay, so now we believe that due to the mentioned reasons, the EMFs induced in these coils are bit different. The complete EMF in this first parallel path may be 100 volts, and the second parallel path may be 99 volts, and third parallel path may be again 100 volts, and the fourth parallel path may be 98 volts. Due to the previously mentioned 3-4 reasons, there may be slight EMF difference in the each parallel path. Right now, this will cause the circulating currents among the loops. Okay, so now how to how we place the this equalizer rings? Equalizer rings are placed, are connected onto the backside of the coil. Suppose if this is the back, this is 1 dash, this is the back end of the connection. So another coil, this is the back end of the connection, suppose n dash. So these two are connected like this through equalizer rings, right? So this back side, you remember, this is the back connection. Where does it lie? Between 1 dash, that coil numbers n dash. So this is here, I show it by some other color. It is here 1 dash. This point is the back end connection. Similarly 6 and 6 dash, this is the back end connection. Similarly 7 and 7 dash, this is the back end connection, and 12 and 12 dash is the back end connection. So a equalizer ring connecting all these points, this is one equalizer ring. Similarly I can connect between 2 dash here, 5 dash here, 8 dash here, 9 dash here, and this is the second equalizer ring. And similarly 3 dash, 4 dash, 9 dash, 10 dash, this will be the third equalizer ring. So I can have 3 equalizer rings for this problem, right, and which are connected to the backside of the windings, remember, right? Not between 2 and 1 dash, or not between 5 dash and 6 dash. It is not here, right? It is not here, but it is between 1 and 1 dash and 6 and 6 dash and 7 and 7 dash, like this. Okay, so the purpose of equalizer ring is to minimize or eliminate the circulating currents, and I have mentioned the various causes of unequal voltages, right? So this is the main idea about the equalizer rings used in the lap windings.